Characteristics of the covalent bond. So in covalent bonds, electron sharing usually occurs so that the atoms contain the electron configuration of noble gases. So this stability results from the fact that the noble gases atoms' outer s and p orbitals are completely filled by a total of 8 electrons. So each atom wants to have 8 electrons. So other atoms can fill their outermost s and p orbitals by sharing electrons through covalent bonding. So such bond formation allows the octet rule, which that's very, very important. So I would highlight that if I were you. Chemical compounds tend to form so that each atom, by gaining, losing, or sharing electrons, has an octet of 8 of electrons in its highest energy level. So the first type of bond is a single covalent bond. It's when two atoms held together by sharing one pair of electrons. So, one pair of electrons. So, we didn't talk about this, but I'm just going to show you how these were originated. So, say we had hydrogen plus chlorine will produce HCl. And I'm going to give you the electron configuration, the outermost energy level. So for hydrogen it's 1s1. For chlorine it would be 3s2, 3p5. Now I'm going to do something called orbital notation. I just want you to follow along here. So if I do that, I want to make sure, I want to spin up arrow, spin down. I'm not going to spin down now. Spin up, spin down. Okay, so we see here that this sublevel, which we talked about sublevels, for both the hydrogen and chlorine are unfilled, they're unpaired. So that means they're going to share this one pair of electrons to make a covalent bond. So it'll look like hydrogen with a single line and chlorine, right? So one single line is equal to 2 electrons. So single covalent bonds. So halogens. When you think of single covalent bonds, think of halogens. They're group 7A. They want to gain 1 electron. So they usually want to have single bonds. Now, double covalent bond, sharing 2 pairs of electrons. So we're going to go ahead and we are going to use, we'll say oxygen. We'll show that. So we have oxygen plus oxygen is going to produce O2. So once again, oxygen 2s2, 2p4 for both of them. The outermost energy level. Okay, so now looking at this, we see that both of these oxygen atoms have 2 sublevels unfilled. So they're going to share both of these pairs of electrons. So it'll be oxygen with 2 lines and then another O. So once again, 2 lines are equal to 4 electrons. So not all the time, but oxygen, you should think of a double bond. because oxygen's in group 6A, and they want to gain 2 electrons, right? So they want to form double bonds. That's not the case all the time, though. Sometimes you might have to guess and check for that. But most of the time, or a good amount of the time, oxygen likes to form double bonds. And then the last type of bond is a triple covalent bond. So we're going to use an example. We'll use nitrogen for this. So say we add N plus N will produce N2. So nitrogen, the outermost configuration, 2s2, 2p3. Okay. So we see all of these sublevels in nitrogen are unfilled. So they're going to share these 3 pairs of electrons. So it'll be N triple bond to N. And once again, 3 lines are equal to 6 electrons. Now nitrogen, not always, but nitrogen is going to form triple bonds, right? So group 5A, remember, forms a -3 charge. Now, there's a few exceptions to the octet rule. And the first one is hydrogen can only have 2 electrons. Beryllium can only have 4, and boron can only have 6. So these are the exceptions that are less than 8. Now the ones that are greater than 8, but they don't have to always have this many, right? Some molecules with an even number of valence electrons, such as compounds of boron, also fail to follow the octet rule. A few atoms, especially phosphorus and sulfur, expand the octet to 10 or 12 electrons. So for example, sulfur hexafluoride, which is the picture right here. All right, like I said, it does not have to, but they can. And this concludes our video on characteristics of a covalent bond.